I'm fine. Mine only did it twice.
Okay, should be. Yeah, it's mine too, so I don't know.
But I could share with you videos that show this as well. So kind of so don't
Just
worry
think
about
it's
that.
nice to
But
watch them after.
yeah. So but okay, and I just want to touch base. Matthew, does this make sense to you?
Yeah, I think I got it now.
Got it now? Okay. And Olivia, you got this. Who else? Maybe Jody?
Yeah, I see it now. I can't ever imagine where I'd ever need it. But
Yeah, that's yeah. That's always the issue. That's always the issue. There's that disconnect between, what we do in the classroom and real life. Yeah, what you learn in school and, well, what you.
And this is why I drink.
Yeah. Yeah. So that's basically how you do it. Now, there is another thing that I could show you with regards to this, and that is basically the table of values. So if we have, for instance, a oops. Just a minute. All right. So let's say I have an equation. Y equals 2, well, let's just say 3 over 2x plus, oh no, let's use a different one, sorry. Let's go 2x plus 1. Now, because this is an equation, I can plug in any numbers into my x value and find out what the corresponding y value would be. All right. So just like with other algebra, what if x was a.
I just lost volume.
Yeah, I just lost everything.
Whatever you're saying, no one, at least I can't hear it. It just keeps coming in and out.
I can't hear anything either except
I
for you.
can't hear anything either.
Me too.
Okay. How are we now?
Because it's a Monday.
Well, I can hear.
Can you hear me okay?
Yeah.
Yeah.
yeah,
Okay. Okay, I don't know.
like learning. This is like learning math on the radio.
Right?
Wade, you have to watch that video I posted in our chat. It reminds me of our Zooms all the time. You need to watch it.
Okay, I'll do that.
It is, I'm going to warn you now. It's fucking hilarious. So don't laugh too hard. You might hurt yourself. But it's really good. Makes me think of every Zoom morning.
Oh, yeah, I will do that. I'll check that out. So, okay, so what if we were to say, because this is the line, you can basically figure out the corresponding points between the x and the y. So if you were to say, what would happen, what would y be if x was, let's say, 1, or if x was 3, or if x was 6? Well, let's not do that high. Or x was let's say 4. Well, let's see this one here. Y equals 2. What if y equals 2? What if x was 1 plus 1? What would y be? 2 times 1 is 2 plus 1 is 3, right? You see that?
Oh crap.
Your volume just went to shit again.
Yeah.
Yeah.
But side note, is he typing and his pen is writing?
No,
Or is
it's
he writing? Why does it
it's-
sound like someone's typing every time he writes?
it's the click of the mouse. Every time he goes, yeah, it clicks it
Yeah.
every time.
That's right.
Oh, mine's touch screen, so I didn't think of that.
Oh,
Yeah.
so I'd at least like to have that. This tablet's hard doing this stuff on it.
Okay.
Okay, well,
So I'll try to,
Did
let's
he
see.
leave again?
oh my goodness.
I don't know what's going on. It's like it's bumping me out all the time.
Well, and it keeps cutting out your voice. Like we can't hear anything you're saying.
Is this the most we've had in one Zoom class? Is that why? Just too many, or
It shouldn't be. It shouldn't be an issue.
'cause
No, there's Zoom meetings with like 50 people in them
Yeah.
sometimes.
Yeah. It shouldn't be. I don't know. It could be my computer.
It's all
Okay.
you,
Work
Wade.
computer.
It's
What?
all you.
It's always me. So so you see then, if you have this, you can hear me okay right now?
Yeah.
Thought I heard a yeah and a no.
Yeah.
Okay. So this X, okay, this is how you figure out your plot points. If say that X was a 1, right? That X was a 1. Well, what would Y be? Well, Y equals 2 times 1 is 2 plus 1 is 3. Okay. Now, what if that X was a 3? What if that X was a 3? 2 times 3 is 6 plus 1 is 7. And what if that X was a 4? Then 2 times 4
Nine.
is 8 plus 1 is 9. Right?
kind of.
Okay.
Does that make sense?
You want to say that last line again?
Does that make sense?
No, like your equation for blah blah blah. Sorry, I should have been more specific.
Equals
My
9. What
equation?
the-
The 4 one, last one that you said. Say that one again.
Yeah, if X was a 4, Y
Yeah.
would be a 9, right? 2 times 4 is 8 plus 1 is 9,
Got it.
right?
Got it.
So then you plot your points. So when X is 1, Y is 3.
Are you watching a video? No, it's Zoom. Wait. Um,
Oh, hold on. Okay. When X is 1, Y is 3. When X is 3, Y is 7.
Oh, fuck's sake.
And when X is 4, Y is 9. And therefore, there is your line. And I'll just connect this. Oops.
Ooh, I understand it now, I think.
What did you?
I just want to play on Paint with that thing.
I know. I love this program.
Should
So
get it now.
yeah. So there's your line, right? And you can see there is that okay? Oops, sorry. You can see how. Oh, shoot. That's the wrong here. You can see how your rise is what? 2x, which is basically 2 over 1, right, is your rise. And over run. And your y-intercept is positive 1. Well, that's exactly right, because this is positive 1. That's where it goes through the y-intercept at positive 1, right? And then the rise over run is 2 over 1. So it rises 2, and runs 1. Rises 2 and runs 1. Rises 2 and runs 1. 2, 1, 2, 1. Okay? I'm just going to go to now the only other thing I want to show you on here is that your lines can go in just a minute. A negative direction. Okay. Now, when you have something like this, what would be your y-intercept?
2.
Yeah, 2. So it'd be positive 2 here, right? So your formula. And what would your slope be?
2 and then 1.
Yeah, it rises 2 and runs 1. Rises 2 and runs 1. Rises 2 then runs 1. The problem is that it actually falls though, right? Left to right, you read it like a book. Left to right, it's falling. So it's a negative 2.
Oh,
Okay, so if it's going, yeah, if it's falling, it's descending left to right. And you can see that with your table of values then too, right? So if you were to put in, let's say, x equals 1, x equals 2, x equals 3. Well, if x is 1, negative 2 times 1 is negative 2, plus 2 is 0. 2 times negative 2 is negative 4, plus 2 is negative 2. And 3 is 2, negative 2 times 3 is negative 6, plus 2 is negative 4. Well, that's, so we'll see, x is 1, y is 0. Yeah, that's right. X is 2, y is negative 2. Yeah. And when x is 3, y is negative 4. That's right.
it makes more sense to see you do that than just to look at what you wrote. That makes a lot of
Yeah.
sense now.
Right. Yeah,
Yeah.
so table of values is something you always can do. You don't have to though. That's a shortcut. If you're able to look at that graph and come up with the equation, that's fine. But the other thing I want to show you is we have if you have something like this, you have to just watch this. Watch over this is y equals 2/3 x plus 2. The problem you're going to have to do is, if you're making a table of values for this, you want to deal with even numbers. So therefore, you have to think of numbers that, so for instance, if you were to take x equals 1, then what would y equal? Well, x equals 1, 2/3 plus 2 is 2 and 2/3, right? Well, you don't want that. You want even numbers. Because trying to plot x equals 1 and y equals 2 and 2/3 You want to stick with the intersections. So what you can do is maybe, the best way to do it is just instead of 2 over 3, do the opposite. Multiply by 3 over 2. Right? Or something like that. But you don't want that either because that'll give you an even number, right? 3 over 2. Which will give you 1 plus 2 is 3. Well, now you have a positive number on the y, but not the x. So a good trick to use here is you can take 3 times 2 is 6, right? So you multiply it by 6. And 6 times 2/3 is 6 times 2 is 12, so 4 plus 2 is 6. Okay. Or multiples of 3. Basically your denominator. You can multiply it by your denominator or the same number as your denominator. So 2/3 times 3. So 2/3 times 3 gives you what? 2/3 times 3. 2 times 3 is 6 plus this. Yeah, 2/3 is 3. So 3 times 2 is 6 over 3 is 2 plus 2 is 4.
That's really complicated.
Yeah, I know. So that's the problem with your table of values here, is that you're going to have this problem with these fractions, right? You basically take 2 over 3 times 3. And what happens when that happens? You multiply your numerators. That's 6 over 3, right? Denominators, 1, 2, plus 2 is 4. Okay. So again, you could look at that equation and say, oh, my y-intercept is what? Positive 2. Right. And it's a slope of 2 over 3. So it rises 2, 1, 2, and runs 1, 2, 3. Rises 1, 2, and runs 1, 2, 3. 1, 2, 1, 2, 3. Okay. Then. Okay. So again, you can multiply that by positive numbers, but you can see that then if you multiply this by 3, so x is 3 and y equals 4. You see that. And again, sometimes it's trial and error, right? 2/3 times 2 is what? 4/3, right? Okay, 2/3 times 3. 2 times 3 is 6 over 3 is, it's 2. 6 divided by 3 is 2. So you can use trial and error there as well. So that's the only other thing I wanted to show you with respect to that. Okay. Now.
Hold on there.
What's that?
I said, hold on a second. It looks to me like graphing it would be easier than that shit on the right side of the screen.
Me too.
Oh, yeah.
I don't get the, yeah.
Me neither. This one's complicated.
Yeah.
Okay, I thought I was just stupid.
If you can just go
No.
I get the graphs. I get that, but I don't know the right side either. That was, yeah, gibberish.
With the with the table of values.
Yes, like when you're trying to tell us to deal with even numbers, I have no idea how you got 3 and 4.
I agree.
I would rather just put 2, 2 over 3, and I would just rather graph that than try to figure it out.
Yeah, and that's all you have to do. So for your exam, you're going to be given something like this. Graph it. Okay. Well, all you have to do is, positive 3, that's your y-intercept. And then it's a rise of 2. 2x is just 2 over 1, right? Rise of 2 and a run of 1. Rise of 2 and a run of 1. Rise of 2 and a run of 1. That's all you have to do.
Right, that looks easier. Yeah.
Yeah, that's all you have to do. Now, on one question, you will ask to be provided a table of values. In which case, you are going to have to say, you will have to provide a table of values with 3 values in it. And again, you just pick any, but it will be with a whole number. You'll have a whole number for the number that's attached to your x. So you can pick any 3 numbers. I mean, you can pick 3, 6, and 8, whatever numbers you want to pick, right? Well, if x was a 3, well, 3 times 2 is 6 plus 3 is 9. If x was a 6, and 6 times 2 is 12 plus 3 is 15. And 2 times, if x was 8, 16, 19. You do have to demonstrate that for your exam. But ultimately, you're going to have questions where you have to say, from this equation, graph it. That's all you have to do, what I just did here. And you're also going to have things that say, they're going to give you a line. And it's going to say, give you a line, and it's going to say, what's the equation? Well, what's the equation of this line?
Plus 3 for sure.
Yeah, positive 3, right? And what's your slope?
I would say negative 3.
Okay, so find an intersection. Where?
I would
Find
say
all your
negative
intersections.
3 over 4.
Okay. So if you have, find 2 intersections, right? You can say find your, okay, so if you're intercept in here, first 2 intersections you find, what does it drop? 2,
1,
and it runs 3.
3.
Drops 2 and runs 3. Drops 2 and runs 3.
A negative 2 over 3.
More or less. Okay. So negative 2 over 3, right? Now you start to get into trouble further this way because the line isn't exactly straight, but basically that's how you'd figure it out. Most of the time that works. Okay. So on and so forth. 1, 2, 3, 1, 2, or whatever. Okay. So that's what you'd have to do for an exam. Those kinds of things. Now, I can send everybody this graph paper. Do you know how to use Paint? I don't know if it's, or do you have graph paper? Does anybody have sorry. You have graph paper with you?
No.
I don't have any. Nope.
No.
Okay,
I
what I'm
do
gonna,
have.
okay, some of you do. So what I'm gonna do is, what I want you to do, when you're in school tomorrow, what I'm gonna do is I'll send, I'll get the office admins to photocopy, to make photocopies of the
The graph.
of graph paper. Yeah, I have some graph paper. Like this graph paper I showed you up here, I'll get them to, I put a pile of them on one page and I'll just get them to photocopy it. And
and then you just pick it up tomorrow. Use that. It'd be easier doing it on paper than trying to figure out how to use it on Paint. I can't. I don't think I can teach that to you and do it justice. So what I'd like you to do now, if you can, I would say this will probably have to wait till you get your graph paper tomorrow. So that's what I want you to do for your homework, is to do the questions on page. Let's see. If we go back to the Google Classroom for Bridging Math, I have textbook assignments. And I'll give you a short break right away. I got to take a break anyway, and then but what I'll do is assign for you in your Bridging Math assignments. It's written actually on Unit 6, Slope and Rate of Change. That first one, linear equations. So if you look on page 23. Of the Bridging Math assignments. Not the lessons now, we're going to go up to the assignments. Okay.
What page? Sorry.
Page 23. I have it up on my screen that I'm sharing here. Exercise linear equations, 3.4.3. So what I'd like you to do is, for that one, 1A and 2A. So using a table of values, create graphs for each of the equations. So what it's telling you to do for 1A here is it's saying create a table of values for this. So in other words, X and Y, big two columns. X, if X is 1, what would Y be? If X is 2, what would Y be? If X is 3, what would Y be, or whatever. And then graph it. Just the same way I've been doing. And then number 2A, it's same thing. Graph it.
And you want us to do that for tomorrow after we get the papers?
Yeah, you can do that assignment tomorrow after you get the papers. Okay. Now what I also want you to do is I want you to also on here is well, let's see. I want you to try to do, yeah. So 3.5.2, it's on the same page 23. I want you to look at questions 1 and 2 here and try to figure out if you can answer these questions without graphing them. Do not graph these. Just say, can I look at the equations and be able to answer these questions just based on what I see in the equations? So don't graph these, but I do want you to do them. Okay. Now number 3, try to determine what the equations of these graphs are. And again, it's hard, right? Because the intercepts don't show up that clearly. I can tell you that the numbers are just below on the x-axis. The numbers are just below the x-axis. So you actually draw your x-axis right above the numbers. So it's kind of here.
Okay, who the fuck did the?
I agree. I think this is horrible, but do the best you can with it.
I did not see that.
Yeah,
I know,
I can't
it's bad.
see those.
I'll try putting on my glasses and try again.
Okay, do your best with it. Come up with a general, like, how, try to get as close as possible to them. And then,
What page number is this?
24.
page
22,
24.
23? Oh, never
20.
mind. Okay, and you want us to do all of those little graphs?
I would say do 1 to 3. Let's do 1 to
1 to
3.
3,
Hold on,
okay.
I'm just going to edit this.
1, 2, 3.
Numbers 1 to 3. Okay, don't do number 4 because that gets into rate of change, and that's something we'll deal with on the next one. And then what I want you to do is, that's okay. I'll teach you that after the break. So we'll take a break right now. I'm just going to mute mine, but you guys can stay on if you want. and then I'll be back with you in about 10 minutes, and then we'll do the one other small section, and then we should be. Then I'll just give you your assignment.